Okay. So we went over 1 and 2. Let's see. Let's work as this as a class. So number 3. What did we notice about number 3 here real quick? There are 2 equations in this step. Where did they come from? Yeah.
It's the oxidation and whatnot from the top equation.
Okay, so it came from the top equation. It came from the top equation, and it showed the reduction, and it showed the oxidation over here. So it just reduced the separated the reduction and oxidation. Does that make sense? See how it separated those two? Next question. What was balanced in this step? Well, there's nothing changed here. What changed over here? So like our goal, the goal in this entire activity was to see what's the difference. Did anything change right here? Did anything change right here? No. Did anything change right here? Yeah, there was a 2 there. So what was balanced? Hopefully, your answer was carbon. The carbons were balanced. Okay? Why did nothing change on the left? Does anybody have an answer there? There's no carbon. Right? All we're worried about is carbon. There's no carbon. There's 3 and 4. How do we feel about that?
Feel really good about it.
Feel pretty good?
Not feel that good.
Okay. Let's go to 5.
Kind of an expert.
Number 5 says, what compound was added in this step? Well, hopefully from 4 to 5, you noticed water, H2O was added. H2O was added. The second question says, what element does this balance? Does anybody have an answer there? Nobody got this far? Yeah. Balance the oxygen. Perfect. So that has 4 oxygens. That has 4 oxygens. So balance the oxygen. Okay. Let's see. Last question. Why did nothing change in this equation, or in the right of the equation? Why did nothing change here? Well, there's already 4 oxygens there. 2 times 2 is 4. So there's oxygen's already balanced. The right-hand side is already balanced. Okay. Next question. What element was added in this step? DJ.
Me raising my hand.
Oh, my bad. Do you know the answer though? Let's walk through this. Do you notice a difference here? Hydrogen. That's my answer. Very good. H plus specifically. Let's see. How did it balance this equation? How did this balance the equation? Well, we added 8 of them. Why did we add 8? Dawson?
Because there's 8 oxygen.
There's 8 over on that side. So how did it help balance? Because there was 8. Because there was 8 hydrogen in the product. Okay? If you just mention something like that, you're good. Why did nothing change on the right equation? Why did nothing change over here? There's no hydrogen, right? I don't see a hydrogen. Perfect. Does that make sense? We good so far? Okay, next one. The E was added in this step, stands for electrons. Why were electrons added to help balance this equation? Okay, so we had a -5 here. We added 5 electrons. We had 8 positives by the H. There's a negative right there. Okay, what is -5 plus 8 minus 1? 2. Okay, so all of that equals 2, right? We just said all that equals 2. What's the total charge on my right side? What? What are the odds of that ever happening? That's pretty crazy. Now, checking this side. What's the charge right there? Negative 2, very good. Why did we add 2 electrons? What's the charge of 2 electrons? What are the odds of that happening? So why were electrons added? To help balance the equation? To balance the charges. Balance the charges was our answer. Okay. Number 8, we're almost done. Holy smokes. Number 8. Why were the 2 equations multiplied by 2 and 5? Did anybody get this one? Multiplied by 2 and 5. Well, if we're still looking at electrons, what is 2 times 5? 10? So there's a total of 10 electrons there. What is 5 times 2? So it balanced the electrons. Okay, so it balanced the electrons. Does that make sense? Okay. Number 9 says, why was there a change in the coefficients? Why was there a change in the coefficients? See, this went to 10, 16, 2. Well, there was a change in coefficient because we distributed the 2. So what 2 times 5 is 10. 2 times 8 is 16. 2 times 1 is 2. So you distributed. You distributed. We feel good so far? Okay, let's go to the last page. Last one. Okay, oh, I went too far. Here we go. Let's finish strong. What happened between this step, and the previous step? I guess we kind of have to look at the previous step, huh? Oh, what happened here? Does anybody know? Can anybody see it? Between this step and this step. They brought everything together. They put all the reactants together. And all the products together. Put all the reactants together and all the products together. Beautiful. Next one. Do you guys have a little dash in your paper? Let's see. On the very back one. It's kind of hard to see on your paper. There is a little faded dash. So there's a dash right here. And a dash right there. So what is happening in this step? If you have 10 on one side, 10 on the other side, you can just cancel. They just cancel out. So electrons cancel out. You just get rid of them. Okay, the electrons just cancel out. Okay. Everybody good so far? Okay, very last one. Let's see. We did that one. Make sure the equation is balanced. Oh boy, let's see. How many H's do we have on the left side? 16? What it looks like? Okay. How many MNs do I have? 2 times 1 is 2. How many oxygens? Well, this is a tricky one. I have 2 times 4, which is 8. I have 5 times 4, which is 20. What is 20 plus 8?
28.
28. All right.
Oh, man.
This is hard math. Carbon. What is 5 times 2? 10. Okay. Bless you. Okay. Let's check out my H's. How many H's do I have over here? What's 8 times 2? Are those equal? Yeah. Mn. What is 2 times 1? 2. Are those equal? Okay. Oxygen. What is 8 times 1? What is 10 times 2? What is 20 plus 8? Are those the same? Okay. Carbon. What is 10 times 1? It's all balanced. And we're done. That's it. That's it. Okay. Oh, and the net charge. Let's do the net charge. I skipped that one. What is 1 minus 1? 0. What's 0 plus 2? Okay, so the net charge on the left side is 2. Well, there's no charge there. There's no charge there. What's that number right there? Nailed it. Man, no one's walked in this hallway for a minute. All lights are off. That's pretty crazy. Okay. So let's see. Did that make sense? Not too bad. Not too bad. All right, let's. Gamma. Gamma entered earlier. Always watch out for gamma. Okay, so let's check this out. How's that paper towel? You gotta crumble it up first.
Oh, really?
Yeah, it's a trick. All right, so hopefully that kind of made sense, guys. Now, let's talk through. Yeah, we got time. What time do we get out of here? 13? 13. Oops, somebody walked in the hallway. We'll start. We'll start. What? What? You made a loud sound.
No, I didn't say anything.
Oh, okay. So, step 1. Write down the steps in balancing redox reaction equations. Use the back if more room is needed. So what happened in step 1? Go all the way back to the beginning. What happened in step 1?
Balancing stuff.
Freaking, the guy was.
Very good. You assign oxidation numbers. You assign oxidation numbers. What happened in step 2? You analyze what was oxidized, what was oxidized, and reduced. Number 3, what happened in number 3? You split them, right? So you created, let's see, you split the 2 reactions. Right? You split the 2 reactions. We created oxidation and a reduction. Number 4, what happened here? This one's tricky. Number 4, we added coefficients. We added coefficients to balance all the elements except hydrogen and oxygen. That one's kind of a long one. Okay, you balance all the elements except for hydrogen and oxygen by adding coefficients. Okay. What happened in step 5? we added water to balance oxygens. We added water to add. In step 6, we added H plus to balance hydrogens. Okay. Let's see, step 7, we added electrons to balance the charge. Okay, added electrons to balance the charge. Step 8. Let's see, we're getting pretty close. Step 8. How's the best word to write this? Add coefficients in front of the entire reaction to balance electrons. Okay. Step 9, you distribute. Step 10, you combine the two equations. Step 11, cancel electrons. And step 12 is basically your celebration step. That's pretty crazy. Okay?
That is insane.
That is
It's
insane.
a lot of hard work and dedication.
That is.
I'm glad we learned.
But what's crazy is
It all pays off.
our future. Yeah.
It pays off. If I've learned anything today, that's
Hard work pays off.
It pays off.
But our future
No matter what you know.
probably going to be. I'm leaning towards like open note with it. Everything open note.
open note. Say
You
that.
say open no.
Open note.
You
This
didn't
is what
say
you're
that
gonna do.
before we took the notes.
You're gonna.
Would that have changed
This is
your
what you're gonna do.
factor?
So you're gonna do open note, but then you're gonna have a review guide that's the same as the test.
Wow.
And then we're gonna write the review on our notes and use our notes.
Interesting.
Here's what I'm
Do you
thinking.
think that would
No
help?
test because this is way too
I
hard.
think that would help.
You know darn well nobody understands.
He just
said he could take a test on it tomorrow. Yeah, let's get that.
Even open note?
Yeah. No way. No way open note would help.
I'm going to work on that.
Okay.
All right. Let's see. Have a good day.